Welcome. In this video, we're going to take a look at a practice problem involving the photoelectric effect, which is basically using these equations right here that can be found on your equation sheet. There's different types of problems you might see involve energy, frequency, wavelength. So it looks like in this problem, it gives us an energy. Whoops. And the first step in any problem solving is always just figure out what it is you're given and what you're trying to find. So we're given the energy is 5 times 10 to the negative 19 joules. And it looks like we're trying to find the frequency. And if I'm not sure what the symbols are on our equation sheet, it always shows what the symbols are on the right-hand side. So just look there. It looks like this is our symbol for frequency. It looks kind of like a V. And then we're looking for an equation that might show a relationship between frequency and energy. And that looks like this equation right here would be relevant. It looks like energy equals H times V. V is the frequency. H, it looks like, is this thing right here. It's also given to us on our equation sheet. So since we want to solve for frequency, I'm going to do a little bit algebra and rearrange this. So frequency is energy divided by Planck's constant. Okay, so I'm going to rewrite this over here. So frequency is energy, which is 5 times 10 to the negative 19 joules, and then divided by Planck's constant, which is 6.626 times 10 to the negative 34 JF. So that's joules times seconds. So when I plug this into my calculator, I got to be careful that I plug this in correctly. And what I would recommend doing is when you type it in, use that exponent button on your calculator. It might look like two capital E's next to each other, but each calculator is different. So hopefully at this point you have discovered this button on your calculator. But if not, talk to a friend or Google it. Yeah. And so you're going to plug this in your calculator. And what you should get here is if you go 5e negative 19 divided by 6.626 e negative 34. I should end up with a pretty big number because I have a small number divided by an even smaller number, so I'm going to end up with a large answer. So my answer ends up being 7.5 E14. And so the way I should write that is 7.5 times 10 to the 14. That's what that E stands for. And if I'm trying to figure out what my units are, look back here at the units of these values. So this is in joules. This is in joules times seconds. So notice how joules cancel out. And what I'm left with is an inverse second. So those are my units. I can write it as 1 over S, or I could write it as S to the negative 1. And that's my frequency. Now I want to calculate the wavelength, and I want to find it in nanometers. Okay, so wavelength, it looks like, is this right here, is the lambda, that's wavelength. And it looks like we know both energy and frequency. So I want to see what's helpful for finding wavelength. Well, this equation involves wavelength. So it looks like that's the equation I want to use. C equals lambda times the frequency. If I rearrange it to solve for wavelength, which is that lambda symbol, it's C divided by the frequency. And what is C? C is the speed of light, it looks like. So any of these constants are always given to us here. So C is 2.998 times 10 to the 8 meters seconds minus 1. In other words, that's meters per second. It is a speed. And then our frequency we just calculated, 7.5 times 10 to the 14. Its units are also S minus 1. So right away I can notice, hey, I've got S minus 1 divided by S minus 1. Those are going to cancel out. It's going to leave me with an answer that is in meters. Okay, so pay attention to your units. You figure out the units of your answer by looking at the units of, the numbers you use to get there. Okay, so label units in your work. So I'll plug this in my calculator. I know it's very exciting to listen to me plug into my calculator. And I'm going to end up with a small number because I've got, a big number divided by an even bigger number. I end up getting 4, let's see, 4.0, if I round it to 2 sig figs, times 10 to the negative, let's see, 1, 2, 3, 4, 5, 6, 7, 10 to the negative 7 meters. But the question asked me for nanometers, and this is the one thing that is not on our equation sheet, is the meters to nanometers conversion. When you hear nano, think 9. So 1 meter is 10 to the 9 nanometers. So nanometers are small, so there's lots of nanometers in a meter. So to convert this into nanometers, I'm going to say, okay, for every 1 meter, there are 10 to the 9 nanometers. So when I plug that in, I'm running out of room here, I should end up with 400 nanometers is what it works out to being when I plug that in there. If I'm typing this in my calculator, I might do this. I might say 4e negative 7 times 1e 9. So give that a try and see what you get in your calculator. Hopefully you get 400, or 399.7, which rounds up to 400. All right, hope that helps.